And I think I can illustrate that probably most effectively with this little recording. Some of you, I'm sure, will recognize what it is straight away, but if you do, don't tell anybody else. See if you can deduce what kind of an instrument this is. Well, I'm sure many of you would recognize what that was, but some of you might not have done. What we did, in fact, what I did, was to play a piano, starting with the last note of a piece and playing back from the last note to the beginning. And then we turned the tape round so that the tune came out the right way round, but all the notes come out back to front. Now, the typical way in which a piano note starts is a very sudden, it's a bit like the guitar that we had on earlier on, a very sudden start and then a slow decay. So if you turn it back to front, we get a slow rise and a sudden decay. And so what was happening there is that you were hearing the slow rise. And I think if you hadn't heard that sort of thing before, you might have thought it was a harmonium with a leaky bellows or something of that sort, an organ-type instrument. And yet, the more you listen to it, the more you realize it isn't that. And the reason you think it is at first is that the starting is exactly the way an organ starts. The reason you begin to have doubts later on is that the brain checks back to see and finds that it's got this sudden ending. And no organ ever had that sudden chop off at the end. And so you begin to have second thoughts about it. But it does illustrate how important that starting bit is. Perhaps I can illustrate it again with some more recordings. This time, these are entirely synthetic. What I'm going to do is to play you what is in effect just a sawtooth. It's just, you remember when we added all the harmonics together, we got that sawtooth. Well, it's going to be like that, but what I'm going to do is to start it and stop it in different ways. We're not changing the harmonic content itself, and I'm going to turn the oscilloscope right down so that it's very slow, and I think we'll then be able to see much more easily what's happening. And here we go. Sorry, I didn't go quite far enough back. Let's try again. Well, I think you could see there that we were just turning it on and off. Suddenly on, suddenly off. And it sounds very electronic, doesn't it? There's no question about that. Now we're going to turn it on rather more slowly and chop it off, a bit like the organ sound, like the backward piano sound. Sounds quite different, doesn't it? Now we're going to do it the other way around. We're going to start it suddenly and then let it decay. Again, quite different. Now we'll go up and down slowly. It's beginning to sound quite a lot different, isn't it? Now, you remember I said that the ear-brain system seems to like a little bit of imperfection. We put a little bit of wobble on it now, what we call artificial reverberation, and it does this. And it's almost beginning to sound as though it might be a rather cheap violin, isn't it? Or something bowed. Not very, but a little bit. Now, the reason it doesn't sound very like it is that those are notes that you wouldn't ever play on a violin on the open strings. But if we have the actual notes that correspond to the open strings of a violin, listen to this. Now that's entirely synthetic. It's our sawtooth waveform, which is not remotely like that of a violin, and yet it begins to sound a little bit like a rather nasty violin. And part of that is because they are the open notes that are characteristic of a violin. And this is another of the important points that crops up when we're dealing with psychoacoustic research. The actual musical context matters a great deal. And if you're listening to sounds in a musical situation, your reaction to them is quite different from that if you're in a lab. You remember when we had the rubber rope, we got patterns with nodes at certain places, points where there was no displacement. With a plate, which is two-dimensional, we get lines where there's no displacement. And if I scatter sand on the plate, and I'll get out of the way of the television camera, you can see the sand going on, what will happen is that when I start to bow, the sand will dance around where there's a lot of vibration, and it will tend to collect near the lines where there's no vibration. Well, it's always a bit dangerous to predict what you're going to do, but I always like to do it here and see what happens. What I'm going to try to do is to produce a St. Andrew's cross, two diagonal lines with a little semicircle in each of the quadrants. And we do that by placing two fingers on so and bowing there. And now, since the St. Andrew's cross is Scottish, and I happen to be English, what I'll try to do now is to repeat that pattern, but to add a St. George's cross as well on top. And you'll notice that not only do we get a different pattern, but the note that it produces is different. I think we've got enough sand on now. Now, to do that, we need 3 fingers on it, like that, and to bow it between 2 of them. And there we get the St. George's cross added to it. Well, I usually say at this point that the one thing I can't do is a Welsh dragon. It's that's a bit beyond me. But there is one more pattern. You could go on doing this all night. It's great fun. I said I enjoyed doing demonstrations, and it's the sort of thing that you could go on forever doing, because there are very large numbers of modes, and they all have their characteristic frequency. One that always intrigues me is one which has a perfect circle. Although this is a square plate, it has a perfect circle with various radial lines. It's much more difficult to get than the others, but we'll see if we can get it. No. No, that's not it. That's not that. That's not a perfect circle. There it is.